The first step is simple. You just multiply the decimals as if they were whole numbers. So you don't even worry about the decimal when you first start. All you do is take the numbers and multiply them. So this is 4 2/10 times 6/10. I'm going to pretend that this is 42 times 6.
42 times 6.
Now, even though it's not 42 times 6, I'm going to pretend that it is. You just multiply like there are no decimals. So when I multiply multi-digit numbers, I know I start, the bottom number is called the multiplier, the top number is called the multiplicand. So I take the multiplier, the ones digit in the multiplier, and I multiply it into each digit in the multiplicand.
Oh, I get it.
So here I say 6 times 2 is 12. So I'm going to carry the 1 over, and I'm going to bring down the 2. Then 6 times 4 is 24. Then I'm going to add the regrouped value. 24 plus 1 is 25. Now, if it has a 0 at the end,
252.
you don't need to write any zeros. It doesn't do anything for your problem when you're multiplying with decimals. If the number ends with a 0, do not multiply it. You're done. So that's the first step. I just take my decimals and multiply the digits like they are whole numbers. Okay? So now I'm going to go to step number 2.
Already?
Yes, already.
What is Mr. Pepper? What is
This 2?
So.
6 times 2 is 12, so I carry the 1. 6 times 4 is 24, plus 1 more is 25. So I had a regroup value. Great question. Okay, now, the second step, when we're talking about division or multiplication of decimals, is I'm going to place my decimal point in the problem. Now, when we think about this, with just like we did, I had 4 2/10, I had 6/10. I came up with, now in this problem, you guys, I have a 10th times a 10th. What's 10 times 10?
100.
So I need 100th in my answer. Just like that problem we just did, right? But if I count my decimal places, I notice that there's 1 decimal place here, and there's 1 decimal place here, for a total of 2, which means I need to have 2 here. So it's 2 52 hundredths. You guys, don't worry about it. Worry about your work. Okay. Now I'm going to show you a couple extra shortcuts that we're going to be talking about as we do this. Okay. You mean here? No, this shows the first step. You multiply the decimals like they're whole numbers. The second step is you put the decimal point in, and that's where it shows the decimal point being put in. Okay, so when you're finished with step 2, just draw a line, and then I want you to put examples, because I'm going to show you some examples. Okay?
That's all the steps?
That's it. Multiplication of decimals is simple.
If that's only 2, if that's 2 and 6, how did you get 1 and 1?
There's 1 decimal place here. There's 1 decimal place here. So it's 1 and 1 make 2 decimal places, right? So I have 1 and 1, which makes 2. So I have to go over 2. I'm counting the decimals of the fractions, or of the numbers. Okay. But really what I'm doing is I'm multiplying them, right? A 10th plus a 10th equals 100th, so I have to go over 100th in my answer. Okay. Okay. I'm going to give you a couple minutes to catch up. So I'm going to pause the tape so I'm not. Okay, so now I'm going to show you guys a couple shortcuts when you're talking about multiplication in general, just not with decimals. So first of all, when you're talking about problems that just involve multiplication, you can multiply
Can we write that now?
in any order. So here's your problem. If I give you the number 20 times 6 and 2/10. 20 times 6 and 2/10.
So it would be 20 times 6.
So I can either set up this problem like this, or I can set up this problem like this. So in this problem, you guys, the multiplier and the multiplicand, I can choose to be either number. Okay, and I know that because of the commutative property of multiplication, right? You don't need to write this part, but 6 times 4 equals what?
24.
But if I change the order, does it change my product?
No.
No. So 20 times 6 and 2/10 is the same thing as 6 and 2/10 times 20. It doesn't matter the order I put them in. And now here's why this is important. So everybody put their pencils down. I just want you watching. This is why this is important. If I look at this problem, this is double-digit multiplication. So I have to start with my ones digit in my multiplier, and I'd say 2 times 0 is 0. 2 times 2 is 4. Then I have to put a placeholder. 6 times 0 is 0. 6 times 2 is 12. I then have to add my partial products, and then I have just one decimal place. So my answer is going to be 124.0, but the 0.0 is nothing. Okay, look at the problem. Now, this one, now pay attention. If I'm multiplying a number and it ends with a 0, so 6.2 times 20 ends with a 0, all I have to do is bring that 0 down. And then start multiplying by the 2. 2 times 2 is 4. 2 times 6 is 12. I put in my place value, my decimal point.
I don't get it.
It's 124.
Well, that was because that was.
Look at the difference. If it ends with a 0, all you have to do is take that 0 and move it down into your answer, and then start multiplying.
Oh. What? I don't get it.
Okay.
I don't get it.
If I go 0, 0, and then I put my placeholder, and then I go 4, and I go 12, then I add this 0, all it did was make a 0 in my ones digit, right?
Oh, I get it.
So then when I went to my second, this was already going to be a 0. So if I just move it down, then multiply, I get the correct answer. Okay? So the answer to this is 124. Now it says 0.0, but if it ends with 0.0, I don't need it. Okay, so write it, go. Just the 6.2 times 20. Okay, if you have a number that ends with zeros, put that on the bottom to make the multiplication easier. Okay? Okay, here we go. The next one I want you to do is if you have a fraction and a decimal. If I have 1/2 times 2 and 6/10, I can do one of two things. I can convert my fraction to a decimal, or I can do my decimal to a fraction. Either way will give me the correct answer, but it's always going to be easier to take the the fraction and make it a decimal. 1/2 is 0.5 because you have a lot of them. But let's just say, but it's easier to multiply by fractions, right?
Yeah.
So if this is 6/10, if I take 1/2, this would be 2 and 6 over 10, right?
I get it.
So then I take my 1/2 times 26 over 10, because I said 2 times 20, 2 times 10 is 20, 20 plus 6 is 26, the denominator stays the same. So this becomes 26/20ths. So then it would be 1 and 6/20ths. I divide it by 2 over 2 to get 3/10, so it's 1 and 3/10, or 1.3. Okay? 1 times 26 is 26. 2 times 10 is 20.
So then how did you get 1 and 6/20ths? I don't see a 6 on there.
I divided. One time there's 20, that's 6 left over, so there's 6, and the denominator stays the same, 1 and 6/20ths. I just converted to a mixed number in my brain. Right? If I have 26/20ths, and I divide it to convert it to a mixed number, 20 will go into 26 once. I multiply, I subtract. There's nothing left to bring down. So the remainder becomes my new numerator. My denominator stays the same.
Do we write the dividing?
So 1 and 6/20ths. And I reduced it to get 3/10, and 3/10 is 0.3.
Isn't it remembered by 3?
What? I reduced it.
How about the 6?
Simplest form, right?
Here, do we write the division problem?
All right, so now take out your whiteboards, mark this, erase, and fraction.